the Rush 5 was a difficult project to work on. Each year, every glider gets more and more difficult to work from. But what we do is we take ideas from all the other projects that we learn. Because we've got quite a wide range of wings, we're working on very high aspect ratio competition wings all the way down to basic school wings. And in that process, we gather a lot of information and learn lots. And some of it can filter down, some of it can also filter up the other way. We make gliders that we as a team enjoy flying and drives and makes us happy and makes us give that special feeling on the inside which certain wings can give and other wings don't. So we do look at the competition and what they do, but only when we get an opportunity or an off chance. But it's not something that really drives us. It's more improving our previous product and making the best wing that we can. The Rush has to tick many boxes. It's a wing that's designed to be safe and forgiving in the E and B category, so it has to be able to fit inside its certification box. But at the same time, we want the wing to give a solid intermediate pilot a wing that's really good fun and enjoyable to fly. We also really try and keep our wings as solid as possible so that they're structurally very strong. And in doing so, that makes life a little bit more difficult for certification purposes, but it makes the wing much more pleasant to fly in strong thermic conditions. It's always hard to make it better. As we get into the apex of design, and I'm not sure if we're there yet, no one knows if we're there yet, but it seems that the gains are becoming more and more difficult. The cost of wings are going up because of the structure is more complex, the materials are more complex, and the way they're constructed is a little bit more complex. For example, mini ribs in the trailing edge, plastics in the leading edge, transversal shaping. The Rush 5 has triple transversal shaping, so all of these small elements add up to more and more costs for diminishing returns. But performance is always really important. Performance allows us to fly further, it allows us to fly better, and just small gains in performance can make a big difference in overall efficiency in cross-country flying. Yeah, I mean, back in the day, top speed of the wing was 43 kilometers an hour, and it was collapsing at any opportunity at that speed. Whereas now, the trim speed's around high 30s, and top speeds are in the 50s area, and the gliders are solid and usable throughout that speed range. There's plenty of differences between the Rush 4 and the Rush 5. What we didn't want to compromise on was the aspect ratio. We wanted to keep a moderate aspect ratio because we believe that aspect ratio is very important for the overall comfort, ease of use and safety of the wing. Not just in passive safety and testing, but when you're in real trouble in the mountains and you lose control of the wing, higher aspect ratio wings are a little bit more demanding in those conditions. So we didn't want to push aspect ratio, which is one relatively simple way of improving performance, but we achieved it in other areas. We're constantly looking for ways to manufacturing processes to really clean the leading edge and keep the nose as wrinkle-free as possible. So we've used triple transversal shaping or 3D shaping, triple 3D shaping in the nose, and that way we can reduce the ballooning effect or the creases created by the ballooning effect in the leading edge because of the double curvature. We've also cleaned up a little bit the trailing edge and have internal structure changes that solidify the glider in turbulent air. If you were to fly both wings in absolutely calm air, the demands are very similar. They're not that different. The Rush 5, though, because of its lower aspect ratio, has a slightly longer brake range, so it's a bit more forgiving in the brake range, which, again, in calm air doesn't make a great deal of difference, but when you take, if for example, you were to take a big collapse in the mountains and you slightly over input, then you're less likely to get yourself in trouble with the Rush 5 by inadvertently stalling whatever you've got left flying and so on. The behaviour in frontal is a little bit more frank, it opens a bit quicker. But other than that, the differences are not that huge. I think most of it comes from the management of the aspect ratio in strong turbulent air. With the Rush 4, we used collapse lines for certification, which have been banned subsequently with the Rush 5. So we had design issues that we had to get over in order to achieve that. And we had to do that without compromising the solidity of the wing, which was something that we were all very adamant about. We did not want to make a weak wing accelerated. So that posed its own problems. From a trimming point of view, it was relatively simple in the end with the prototypes that we had. It didn't require a great deal of twisting, detwisting and the like. But what we did do is we fortunately had enough time to be able to spend 3 weeks working on the brakes, just the brakes alone, so that we could really find the perfect mix of roll and yaw that we all really enjoy in the wings that we fly. We always aim to have the wing that has quite easy roll and yet is yawing in the turn so that it can stay flat and efficient above the head. And it's really pleasurable to fly when it's like that. So we were fortunate that we could spend that time just working on the brakes alone to really polish the wing off. It's always about finding a compromise and a balance. It's always the way. If you loosen up the sail, if you reduce the tension in the straps and shaping in the panels and so on, you can make a wing more alive and more feely. But that can be understood by some pilots as too much information, and by other pilots it's perfect. So we're trying to make a wing that has a broad appeal. And we do personally like wings that are very strong. We also, as you know, here where we fly, it's quite a choppy place to fly, so it's good for development because it means that we can make wings that are solid in choppy conditions. No, the tautness and the tightness is good for performance, and it's also good for the solidity at full speed and the trim speed. But it comes down to personal preference. Well, the shark nose is just the opening. Yeah. You know, there's the rest of the profile that you have to consider. There's also the structural integrity of the wing with its spanwise straps and the way the diagonals are made and where the diagonals hold the tension and so on, along with the line layout, the line tab positioning, the angles of the lines. It's all interrelated. You can't, often when you have a problem, for example, if you have a problem with a wing and you think there's one simple solution, it's not always the way, because it's a complex interrelation between all the different aspects. Yeah, we use the materials that we believe are the best on the market and offer the best compromise between weight and durability and structural solidity and so on. So we like to keep a good, strong internal structure that allows the wing to age well after many, many years. We don't get big deformations in the top surface after 100 hours or so. But weight is a consideration that we do keep in our designs, but I think we're not compromising too far that way. No, I think you just got to go and enjoy it. I think the handling is there in the precision, but you can really use the second part of the brake range as well. So a bit deeper down to create bank and roll. And use the brakes, I think, is the most important question. The most common mistake I see intermediate pilots make, which is good, is the very gentle with the brakes and not really inputting the glider as positively as they can do. I mean, that's not always the case. There are pilots who are a bit too heavy-handed, but no, I'd say my advice would be to use the brakes and use the speed range of the glider when it's safe to do so. The Swift 5 is it's ready to go for certification, and it will probably be released, all being well, at probably the end of this summer. Okay. Around St. Hilaire time, I would imagine.
And what sort of weight difference are we looking at?
I don't know off the top of my head. Normally we gain about a kilo. We normally gain about a kilo.